We have Jupiter and CJ. Can I hear you? You guys there?
Hello.
Hello.
How's it going?
Good. How are you?
Great. Doing great.
Fantastic. Thanks for being here. The last ones, and I'm super excited. I've told the group already who are here. Thank you for still being here. If you're on the phone, there's been a long day, so really appreciate it. And I'll have to tell you guys, this is the one from TC that landed in the top 10. So I'm excited to see it. If you didn't get to see it at TC, here it is. So without any further ado, Jupiter and CJ, you are up.
Thank you so much. Okay. First of all, can everyone hear me?
Yes, we can hear you.
Okay, perfect.
Yes.
Just making sure. Awesome. Yeah. So with me today is CJ Jacob, my co-presenter at Tableau Conference. So CJ, my understanding is we'll just be kind of moderating, making sure questions are getting answered and whatnot. My accurate understanding, CJ?
Yep. You're going to take it away, and then I'll just be here as support and check the chat for any questions.
Awesome. So if you guys do have questions, feel free to go ahead and just put those in the Q&A section, and we'll get started. Just know this is more of a trimmed down version of the session we gave at TC. Unfortunately, we couldn't get it set up for the hands-on portion, but we're at least going to go through the material, and hopefully you guys can get some good stuff out of it and be able to try some of it yourself. Forward-looking statements. I don't think there's anything here that we're talking about the future, but just in case I do say something future-facing, this covers me legally, so go ahead and just read that at your own pleasure. Let's really start again with integrating Tableau and Python in the world of data science. That's always been a hot topic that Tableau has been very passionate about, as you all know. It's something we're aiming to do. So that's the name of our session here. Again, just for context, this is myself and CJ, my co-presenter, just our information. So if you want to reach out or connect with us on LinkedIn, feel free. As far as agenda, today what we're going to be talking about really quickly, we're just going to be covering a little bit of an overview of advanced analytics, where Tableau falls into that space, a section of the presentation that we fondly called When Tab Met Py, and finally a little behind the scenes of like what makes this, how the sausage is made within kind of these different processes that we do to integrate Python with Tableau. So let's start with the why. As we all know, advanced analytics really does break down into 4 different stages. There's the descriptive, the diagnostic, the predictive, and the prescriptive. For a long time, Tableau's really operated within the descriptive space, and you could argue the diagnostic space as well. We've dabbled in predictive, but very candidly, we don't really have the tool set that really falls into that, and especially even in the prescriptive space. Now, there have been other players that have really done good work with that, and that ranges from a variety of different startups, but really the fundamentals of where it all begins are in Python. That's really where the majority of those things are being created by the open source community to kind of enable those of us who are interested in pursuing more of those advanced analytics to be able to do them in an easier way. So what are we bringing to the party? Oops, sorry about that. There we go. We're bringing a couple of things that I think are very critical to these scenarios. We have data connectivity, the ease of exploring data, and the ability to tell a story interactively. These are very powerful facets of any sort of analytics project. And so although we may not have the prescriptive and the predictive aspects, we have the ability to bring all that information in to allow you to tell your story in a much more compelling way. Now, like I said before, there's things we're missing. So we look to our friends at Python to help us fill those gaps. So what do they bring to the table? Statistics and machine learning, productionalizing predictive modeling, and more expressive power. Now, what do I mean by that? As we all know, we have SciPy, scikit-learn, TensorFlow, and a ton of other different project libraries created in Python to help data scientists, analysts, etc., and enable them to leverage this new field of statistics and machine learning that is the AI space and ML space. So you have things like building predictive models, building natural language processing machines, computer vision, all of that. But at the end of the day, you still need a way to kind of bridge that gap and provide that to your end user. So that's where Tableau comes into play. Being able to productionalize, again, as I mentioned before, there's so many packages out there that help you with packaging up those models into something that you can ingest and put into production to be able to actually use those predictions for live scoring or for anomaly detection, whatever it may be. Finally, expressive power. Because Python is built to be open source, it does give you so much more flexibility than an enterprise tool would. Let's think about it. I, as a user, could tomorrow go and build something that might accomplish a task that is very manual today. Maybe it requires a lot of different code, a lot of different algorithms, but with a few lines, with a few hours of work, I can create a package that then calls one function that does it all for me. Is this something I have to go through and do a lot of testing on? I mean, I should, as a good developer, right? I should do some testing. I should make the code accessible for people to be able to find bugs, find loopholes, whatever it may be, to like patch those things up. But in theory, I could just take that and run with it. In enterprise, that doesn't really work that way, right? You have to find a way to integrate it across all different platforms, across your own technology stack, across what people are installing. So the expressive power comes from more flexibility in that sense to be able to try new things. That may not always be the most preferred or best option, but at least the ability is there so that you can kind of take the risks that you want to with a tool like Python that gives you that flexibility. I think that if we did that with Tableau, people wouldn't be too happy. Hence, we give you that expressive power in Python. So a little brief history. For those of you who don't know, what is Python? It was actually invented as a programming language in 1991 by Guido van Rossum. It was built to be scalable, object-oriented, functional, and flexible. Back then there was a lot of different coding languages that were being developed, and they all had their pros and cons. And Python was really looking to be the one that was the one-size-fits-all kind of language that could really accomplish it all. Now, for a long time, that's kind of what Python was, and I think it still is considered to be one of the more popular languages that are used, programming languages that are used. But as we know, there's more new technology coming out every single day. That's probably going to surpass them at some point. But for the moment, for the time being, at least as far as I checked, Python is considered to be one of the gold standards when it comes to building predictive models and machine learning data science projects. Maybe deploying them Java, but regardless. The best part about it is it's free and it's open source. I could go download it today if I don't already have it and start playing around with it. That's a very big benefit. You can integrate this with Tableau, and it's not another license that you have to purchase. All right, let's get into the how this is working. So let's talk about TabPy. Again, when Tab met Pi. It's been out for a while now. It was available in 10.2. I don't even remember 10.2. It's been that long. So it's been out for quite a while. Very candidly, again, just a little bit of a historical lesson here. I believe it started out as a hackathon project. Someone wanted to integrate Python and Tableau together, so they did it. It landed pretty well. Again, in the open source community, that's how things come to be. And Tableau found it and said, "This is really cool. Let's run with it. Let's make it enterprise ready." So we took it over the ownership. We now have the ability to, we offer support for it. We have a GitHub page. We support its hosting on GitHub, all of that. And we update the code and make all the changes. What's the benefit of TabPy? It is open source because it is in Python. Like I said, we do own it. You have two different components, the Tornado and Tools libraries, which are kind of where all your different customizable factors are in. So you can enable that to do any sort of changes you want to your TabPy server, how you execute different settings and permissions to provide more or less data up to your liking. The great thing about it, it has immediate execution, meaning that the second you open a Tableau dashboard, your Python will run, execute the functions, and it will keep the results updated. If you make changes, it'll refresh them. So it works just like Tableau in that sense, right? It works just like your data does in Tableau. The other benefit is being able to control the data being sent to TabPy. Maybe you don't want to send all of your data maybe there's only certain things you want to be able to send. You have that flexibility to provide what you do and don't want in TabPy. So how is this kind of happening in the background? Let's kind of go through the different steps that it takes. We have the Tableau script, which is an option where you can write the Tableau Python calculation, whether that's through, and we'll get into this a little later. So if you're not certain on like what I'm talking about, hopefully by the end of it, you'll understand. But for the sake of argument, let's just keep it simple with the scripts. Within these scripts, you can call Python functions that you've deployed in your TabPy server, or you can write raw Python scripts that you then send to your TabPy server. What happens is it goes to this external service that essentially takes this information and it translates and grabs the Python code that it needs. So for most part, it's one-to-one Python code. There's a few exceptions with the way you send Tableau variables. You have to use certain formattings, _arg1, to be able to actually use variables in the Python scripts. So those things, for example, do get translated and the data gets pushed and it executes and figures out what it needs to send. And then it converts that to pure Python code. It gets executed within your Python server, wherever your Python is running. And then the results get returned via a Tableau table calculation. So it's a pretty extensive process. You'll find it's actually really performant for the most part. Again, as you start to push the boundaries and get into some bigger data sets, you may find longer wait times. But for the most part, it performs pretty well with like your pretty large data sets. So once you go through that process, you'll probably want to understand like, okay, well, we talked about that, process, but what does the order of operations look like? So this is kind of talking about like the different order of operations for Tableau and kind of where Tableau Python scripts fit in. So again, this is when it comes to like how Tableau operates things. Depending on how you want these scripts to work, you need to keep in mind the order of operations. So Tableau does kind of fall within those first steps where Tableau calculations and Python scripts are computed, and then those filters for both calculations and Python and filters being applied by Python calculations are displayed. But just keep in mind that essentially, densification and data blending happen, filters that depend on blending calculations are applied. So those things will apply first. So just keep that in mind when you are building out these Python scripts. There are certain scenarios where it may make sense to use a Python calculated field, but there's scenarios where it may make more sense to leverage something like table extensions, which we'll be talking about as well. Okay, so how does Tableau send data to the TabPy? This is, again, where we can get into a little more of the specifics around the functions that you would leverage. So we have the script underscore, and then we have a little asterisk there, because if you go into your Tableau calculation pane right now and go to your handy search bar and type in script, you'll find there's about 4 different functions that'll be returned. There's script string, script real, script int, and script boolean. What's the difference between those functions? Well, basically, depending on which function you use, that's going to tell Tableau what expected result you're expecting Python to return back to you. What does that mean? That means that if you're running calculations where your expected output is going to be numbers that are whole numbers, like 1, 2, 3, 4, 5, 6, 7, whatever, then you should be using script underscore int because you're expecting integers to return. If you're expecting some sort of string, maybe that's a yes, no type thing, then you would return a script string or a script boolean if it was true, false. And then finally, for script floats, or I'm sorry, script real, decimal numbers. Maybe these are exact calculations and you don't know if they're going to be whole numbers or not. It's imperative because that's how Tableau expects to receive the information, and it makes your life a lot easier when you follow those procedures, because otherwise you're going to get a bunch of errors. In addition, those functions do work just like table calculations, where the measures that you pass through do need to be aggregated, or they need to be Tableau parameters in order to work properly. So that it does create some issues when it comes to text fields, right? Because the way you aggregate those, you have to create like a minimum or use the ag function, and that grabs like the min or the max. And if you have values that are not unique, then it causes more problems down the line. So keep in mind, it's not perfect. There are going to be situations where using the script functions or even the model extension functions aren't always going to be the best. With parameters, they work pretty cleanly because passing one record at a time. As far as the build of the actual function itself, it's going to work a couple of different ways. Once you put in your script, once you select what your function you're going to use, you would go through and in quotation marks, you would write out your Python code. For simplicity, just using a return statement here to return the original argument. Once you've written out your Python script, you would do as a comma, and then you would provide your aggregated metrics here. These are defined by these underscore arg 1, 2, 3, etc. numbers, and they're order sensitive, meaning that arg1 is going to reference this first dimension that you post. If you were to post another one, that would become arg2, post another one that's arg3, so on and so forth. Again, because you are passing aggregated values, keep in mind that you're going to have different results that are being passed based on what your visual looks like, right? So if you do a visual where you're doing sum of sales over a year, over a month, and you're using that formula to look at values in Python, that value may change. And so you want to make sure that you have the visual that you want to see and the level of aggregation that you want before you start messing with the Python calculations. And of course, just to keep in mind, you can pass other table calculations to these functions as well. So creating nested table calculations can get funky with that as well, but something that you can play around with if you like. So once you've done all this, as I mentioned before, when you pass this information, you're going to get a result back from the Python script. And basically, you're going to get one result per row of the data that you pass based on how you've aggregated it. When you look at the Python as it's being returned, Tableau is expecting vectors to be returned as Python lists. And one of the shortfalls of kind of leveraging Python within a script function like this is that it can't return multiple Tableau measures from a single script. Meaning that if you're looking to manipulate several columns, you have to create an individual calculation for each of those functions. So when I think of use cases that apply for leveraging, your more so like script functions, I think like if you've deployed models within TabPy, if you want to do some sort of clustering, some sort of forecast, things that return like a single output, great functionality. But essentially, if you're going to be returning multiple values, if you want to do like manipulation of your whole data set, EEA type things, it's not going to work all table calculations like this, especially like if you're trying to return a matrix of values, you need to parse it or it's going to error out. Thankfully, we have a solution for that use case. And excuse me 1 second here. Any questions in the chat as I'm going through this?
So far, so good.
Cool. All right, that just gave me a chance to pause and have a drink of water. I know I'm going a little bit fast here. I know we started a little bit late, so I just want to be respectful of time.
No worries. You're doing great.
Awesome. All right. So table extensions is kind of our solution for some of the limitations that we've had with our script editors in Python and Tableau. A table extension is meant to work almost as a pre-processing tool for Python. And why is that? Because when you're passing your data through a table extension, this is done at the original data connection phase where you bring data in, you're passing it as a full data set as opposed to each column. What does that mean? It means that you're only passing one argument, that's underscore arg1. That will define the entire data set that you have. And that means that when you pass that in, you can convert it into a pandas data frame, and you'll take all of the names that you have defined in Tableau, and those will be your column names for your pandas data set as well. Now you can start to play around with this data frame. You can create new fields. You can create new types of data formats. Maybe you want to pivot the data. Maybe you want to take that data and aggregate it a different way. Maybe you just want to add a new field, right? Maybe you have a Superstore data set and you just want to create cost of goods sold. So you could create it right within that data frame, or you could create a brand new one that's in a different structure. All that matters is once you return it, you return the data frame that you want to send back to Tableau. And a couple of caveats here, and it's a little small, and I think the slides might be shared after, so don't feel like you have to squint or zoom into it. But essentially, the way you return these data frames is through a function called .toDict and orient as a list. Essentially, table extensions in Tableau expect the format of the data set that you return in a certain way. So you want to make sure that you keep them happy and you return it that way. But other than that, you can modify and create anything you want, do any sort of EDA. You could build a model. I mean, you could leverage REST APIs to pull data live in from Python and feed it directly into Tableau. So the possibilities for working with table extensions truly are pretty endless in that sense. So script functions, we kind of talked about them a little bit. And again, this kind of shows what I was talking about before, if you weren't really sure what I meant. If you look at script within your Tableau calculated field little help box, you'll see the different options, and you'll kind of see what this looks like from a more like demo look perspective, where you put your code in quotation marks, typical Python code or R code. In this case, I believe this is R. And then you just have to pass the values that you're feeding into this with arg1 and arg2. So as you can see here, this is an example of what that looks like. Another pretty new function we've called is called model extension functions. These work very similar to script, where model extension is model underscore extension underscore asterisk, because there is a real function, there is an int function, there's a Boolean function, and there's a string function. So again, depending on what your output of this model or function that you've deployed into TabPy is, you're going to have to decide which of these applies to that function. Here it works a little different. Why? Because there's been models or data or code that you've deployed onto your Tableau server, onto your TabPy server, that can now be called by someone with little to no Python. So let's take a look. Here, you'll see that I provided the name of the model that lives within my TabPy server. I've provided it the variables that it needs in order to run this model. So in this case, I'm running a home price predictor model. I'm providing the year it was built, how many square feet, and what zip group it belongs to within. So I think this is for city of Chicago. I am from Chicago, hence the reason why I did that. You pass the aggregated values. So the max of year built, max of gross square feet, and the attributive zip groups to be able to run your model. And this is going to take that information and it's going to run it against the model that's deployed and return a prediction for home price. So now I can take this information and I can put it into a visual to show actual home prices compared to predicted home prices, to see how I have gotten, I have gotten a pretty decent end user experience for being able to look at and observe and analyze my models. I think I just saw a question in the chat here. Is this something, CJ, you can answer, or do you want me to answer it? I'm not sure if there's a way to reply to the question or not. I can just take a look.
Yeah, we just keep on going here. We'll keep typing the answer, and if we get to the time at the end. So
okay,
yeah.
Perfect. Sounds good. Cool. Okay, I think I'm actually almost done here, so I should have time for more questions too. Yeah. Perfect. All right. So let's get into some key takeaways. So, just based on what you've heard today, again, very transparently, remote Python execution does provide a lot of needed flexibility to be able to work with functions outside of Tableau that aren't currently available in our stack. And I think that question kind of asks something around that, where there are certain things Tableau just can't do. And they may be things that you would think, why can't we? We're trying to give you that flexibility to do these things without having to wait for a feature request. Keep in mind, level of detail on your dashboard will affect the data set to TabPy. That's going to be critical. If you're not getting the results that you expected, check your level of detail before you think you did something wrong on the code-wise. If you need to leverage an entire data set, or if you need to return multiple columns, table extensions is going to give you that added flexibility of doing so in a very efficient way, but also maintaining all of that workflow in a workbook. There's nothing worse than, and this is personal experience, I've had situations where I need to take something from Tableau, like I need to create a visualization. I realize I can just do this in Python a lot easier. It's too much work to try to figure out in Tableau or Tableau Prep. So I'll create a script, very simple script in Notepad, run it, execute it, read the CSV in, write the CSV out, boom, have a new CSV, upload it into Tableau, we're good to go. Again, this is for ad hoc work in production. That wouldn't be the case. But now what happens if I share this with someone else? If I forget where I put the script, suddenly I have this new data set and I have no idea how I created it. By being able to keep it all within the Tableau workbook, you at least have a point of reference for the work and changes that you've done to your data source if you were to use Python for it. The final point, and again, we didn't really talk about it too much. Again, it was more discussed during the hands-on session, but being able to persist script results and leveraging them as API endpoints is really good for supervised model deployment. Why is that? TabPy Tableau has always been historically really well received by the business users, analyst population for its ease of use and interactability to be able to really simplify leveraging analytics, right? It puts the power in the hands of the users to give them the ability to answer their own questions. When it comes to model deployment and even just testing models, like let's not even get to model deployment. Let's talk about testing models and being able to see if the results are on par with what we've expected. In my experience, a lot of times a data scientist is very good at building a model. They may not always have the industry expertise to be able to provide a model and explain exactly why it's doing what it's doing. I come from a background of insurance, so I'm going to use that as the example. A data scientist may not realize there's just certain things that you can't use within a model, or that if someone's credit score or their insurance score, is higher, that means that the rate should be lower. There's scenarios where the user or the data scientist is going to build the model, it's going to give you the predictions, and they'll call it a day. It has good accuracy, good response, low overfitting, low bias, low variance. And so they're going to say, mission accomplished, we built a good model. But if I, as a business analyst, go in and I notice that as the person's insurance score goes up, meaning that it's a better insurance score, and their rate goes up, something's wrong, right? That's not how insurance works. Insurance carriers have developed these insurance scores to be reflective of a person's risk profile, meaning that if their insurance score is higher, that means that they should get a better rate. So it's those scenarios that can be easy to test out when you provide the business users or the industry experts the models in a format like Tableau, because they can go in, they can play around with the inputs parameters, they can move them around, they can check how the results change, and they can provide their commentary on that if things aren't operating as effective. Now, in theory, as a data scientist, I could take that information, I could create predictions on a test data set, I could export that into a CSV, and I could share it with my business user and let them see the results. What would they have to do? They have to probably go and take that into Tableau anyway, or do it in Excel, chop it up, figure out how the values are correlated, like if insurance score truly, as it goes up, rate goes down, or vice versa. It just creates more work for them. And candidly, they may not see everything that's important to see, because at the end of the day, they're just seeing a bunch of numbers in a spreadsheet. So giving them that end user experience to see it all in interactive dashboards that they can quickly test their own use cases around is going to be such an important value add for them to better provide candid feedback for the data scientist teams. So with that, I just wanted to thank you all so much for your time today. Again, normally we'd have more hands-on training to let you guys test out some of these functionalities, but unfortunately we weren't able to get that done for today. So thank you so much for your time. If there's any questions, I'm happy to take them now.
We have a good one here. Again, CJ, I think you covered this a little bit. Why doesn't Tableau build in some of these models? T-test, Chai, SQL test, sample regressions. This is something Tableau is considering to add, like its repository of analytic procedures, kind of like forecasting and clustering.
That's a great question. Very candidly, I think product management might be able to answer that a little better than I can in terms of why these features haven't been brought on. It very much really comes down to priorities in what Tableau is meant to be. Obviously, when you're talking like t-tests and chi-square tests, very simple statistics tests. You would think maybe those would make sense. Just probably not on the list of priorities, or just something that, again, other tools do it better. Tools like Python do it better. So I think we'd rather provide features that will enhance the self-service analytics experience. And that's where we want to focus the limited resources and time that we have. I know we do have like a line of best fit, which sort of does a simple regression, but I know it is only like one variable, like single variable regression. So there's that. But like I said, I think that Tableau's focus is saying, listen, we want to be the single best self-service analytics platform for visualizations and metrics and things like that. And if you want to take that to that next level where you are doing more heavy statistics, simple regressions, or even just more refined modeling, we're going to provide you the endpoints that allow you to integrate those things into your Tableau dashboards and reports.
That was a great answer, and representing the product org, I would say that's exactly right. It's more about priority, and like you said, I think Python does it better. I agree with you. I think we probably could do a better job of integrating them in a more seamless way. Maybe not making it as hard. And I know we do a good job of trying to lower that barrier, whether that be TabPy or making some advanced functionality like that. But yeah, that's the answer, really. Does anyone else have any more questions? Questions for Jupyter? Questions about data devs at all? Any of the sessions you saw today? I do again if we're waiting for people to come and chime in. I really appreciate everyone's time today. We got 200 people holding strong here, so I'll close this out while. Oh, we got a couple. I know a little bit about creating data science models, regression, classification, and I know how to use Tableau. But do you have a link that would go further detail about model deployment and linking it to Tableau?
Yes. So we have our TabPy GitHub that provides a good overview of TabPy and how to use that. So I don't know if I can share that link out. If I post it in the team chat, are you able to share that out, Kevin?
Yeah, we'll put it in. Okay. We'll put it in. We'll answer your question. We'll answer your question, Chris, with the link. Yep.
I forgot I can reply to those. Here we go. This should work. Okay. So this is the link to our TabPy GitHub. It provides an overview, of a more in-depth overview of TabPy, installing it. The great thing, Chris, is you can install it locally on your machine, meaning that if you wanted to start testing it right away, as long as you have Python on your computer installed, you should be able to play around with it. It provides some sample code on how you deploy the models into TabPy server. And I think there's some blogs as well that we may have that may provide a little more to Tableau. Let me see. Okay, this. Yeah,
and another good question. Love that we can connect to APIs using TabPy, but are there any perspectives of having specific data connectors to APIs? We do have the Web Data Connector 3.0. That documentation, I'll link to that as well. But you can essentially create a connector to REST endpoints. So you got a couple different options, whether that be table extensions with Python or creating your own connector to grab that data out of it. For example, Marcelo, I know you've been on the call most of the day today. We really appreciate it. But we're building the same team. We're building interested in working with Workday, building those data connectors, and it would be kind of the same type of connection. We built a web data connector actually to the metadata API, so you can kind of siphon in that data that way as well. So you got a couple of different options there as far as pulling data in from an API's perspective. Can we put the GitHub link address to the Ask Questions form? Yeah, we could do that. And Raj, thank you. I appreciate the kind comments and the kind words. I know a lot of people have been on here all day. Again, I want to thank everyone for their time. We had great numbers. I really loved all of you here and all of the questions. That we're almost up to 130 questions, which is amazing to see. I really appreciate your time again. Again, we're hoping to do another one of these in the fall. Should be a survey that when I believe that you exit, you will be able to submit some feedback. Again, there's a lot of places to find us. Find me on LinkedIn, connect with me on LinkedIn, find us on the Slack channel, find me on Twitter. I'm around. So thank you so much for your time today. If you want any more information, again, find us and talk to us. We're around. Thank you again for your time, everyone. I hope it was beneficial to all of you. Have a great rest of your day. Thank you.